Welcome and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe the channel. Today, in this video, I will discuss syllabus content of the Chemistry 5070 and the topic which is added in the syllabus and topic which is omitted in the syllabus and how to describe this. State the distinguished properties of solid, liquid and gas. This is very simple, but describe the structure of solid, liquid and gases in terms of particle separation. This is the particle separation. Uh, this is particle separation, arrangement and motion. Motion is, you should know that separation in gas is particles are further apart. Particles are further apart. In liquid, particles just touching each other. This is very important to write down like this. And in solid, particles are tightly packed. This is very important to explain, to understand the term separation, arrangement and motion. In case of arrangement, so arrangement is like uh, in gas, particles are arranged random arranged in irregular manner. In liquid, particles are loosely packed, and in case of solid, particles are tightly packed in regular manner. In regular manner. While discussing the motion, in case of motion, uh, in case of motion, in case of liquid, sorry, in case of gas, random motion. In case of liquid, particles slide over each other. And in case of gas, sorry, in case of solid, particles vibrate on its fixed position. Vibrate on its fixed position. So please keep it in mind, this is very important and this must be coming in the exam. So you should answer of the particle separation, arrangement and motion like this. Examiner is expecting these answer from your side. Okay. Now next topic is describe and explain changes of state: melting, boiling, evaporating, freezing and condensing in terms of kinetic particle theory. So this is old topic and you know that how to explain this. Okay. Now interpret and explain heating and cooling curve. This is also a new addition, heating and cooling curve. in terms of kinetic particle theory. That, for example, this is the heating curve. This is melting point and this is boiling point. This is the cooling heating curve, and you know that melting point is constant when this is over here solid, over here solid liquid, in this uh, only liquid, and over here liquid and gas, and this is gas. So when all solid is going to melt, the melting point is constant, and when all liquid changes into gaseous until unless changes into gaseous state, the boiling point remain constant. Melting point remain constant when until unless all solid changes into liquid state. So if, for example, this is 0 degree centigrade, at 1 degree centigrade the solid become liquid, so it is not solid. So from here to here this is 0 degree centigrade, and then when changes into liquid, temperature is going to increase. So at 1 degree centigrade uh, state of matter is liquid in this case. Similarly, this is heating curve and this is cooling curve. Over here gas, over here gas and liquid, in liquid and liquid and solid, and at this stage solid. And you know this is melting point, again this is boiling point or condensing point. We can say, you can write down condensing, not write down, but assume that this is also condensing, because gas going to condense in the liquid state. When particles lose energy, lose kinetic energy, and ultimately particle movement ceases and close together, slide over one another, and when liquid gradually liquid lose kinetic energy, uh, and particles and lose kinetic energy also, particles come closer to each other and slide over each other, and ultimately when liquid changes into solid state, there is negligible energy, vibrate only on its start vibrating on its fixed point. So this is this is in terms of heating and cooling curve, and you can you should explain in terms of melting, boiling, evaporating, freezing, heating and cooling curve in terms of melting, boiling, evaporating, freezing and condensing. Describe and explain in terms of kinetic particle the effect of temperature and pressure on the volume of gas. Temperature is directly proportional to volume, while pressure is inversely proportional to volume. So when temperature increase, volume is also increased. When pressure is increased, volume is decreased, and when pressure is decreased, volume is increased. Okay, so you should know this concept very well. Diffusion, describe and explain diffusion in terms of kinetic particle theory. And if you ask to define the diffusion, you just write down the definition like um, movement of particles, movement of particles. So write down particles, not molecules, not gas, or not any other word. Movement of particles from high concentration to lower concentration. Describe and explain the effect of relative molecular mass on the rate of diffusion. Only relative molecular effect of relative molecular mass. So this is very important. There is no temperature given over here. So this is very important because temperature is omitted, only relative molecular mass is there. So MR, by increasing, when MR is higher, diffusion is lower, diffusion rate is lower, and when relative molecular mass, and write down in terms of relative molecular mass. Okay, so he has written relative molecular mass, and the marking scheme is based on subject content. So write down relative molecular mass, that higher the relative molecular mass, lower the diffusion, and lower the molecular mass, higher the diffusion. Okay. Elements, compound and mixture. Describe difference between element, compound and mixture. You know that element, definition of element is very important. This is in this way you can define element. Element is a pure substance made up of same kind and size of atom. Same kind and size of atoms. So this is the definition of element. And you know compound is the also a pure substance made up of two or more than two atoms, two or more than two atoms of different element combine chemically. So this is the compound definition. Now next is in context of atomic structure and the periodic table, describe the structure of the atom. You should know the structure of atom, like this is the nucleus, and this is shell, and in the nucleus proton and neutrons are present. Proton and neutrons are present in the nucleus, surrounded by electrons in the shell. So this is the nucleus in which neutron and protons, and this is very important to know the relative molecular mass of the particles. Proton, this is charge, and this is relative mass. Proton, neutron and electron, plus, 0 and negative, and relative mass 1, this is 1 over. You can write down the number between 1700 to 2000. So this is 1 over 18 40th part is the best option, but now examiner expected you that this figure 1840 is the figure between 1700 to 2000. Okay, so must write down in between these two figures. So you can write down 2000 as well, you can write down 1800 as well, 1750 as well. State the relative charges and relative masses of proton and neutron. Define proton number. Atomic number, you are very well aware of the proton number, like this. For example, this is sodium, and 11 and 23. 11 is the proton number or atomic number, and this is nucleon number. And in nucleon number, you know that proton plus neutron is the nucleon number, and proton is also equal to the electron, but this number is proton number. So define mass number. It is also known as mass number. Proton plus neutron present in the nucleus is known as mass number. Nucleon number as the total number of protons, neutrons in this is the definition. Examiner expecting this definition from you, that if asked you define the nucleon number or mass number, this is the total number of protons and neutrons in the nucleus of an atom. Determine the electronic configuration. You know, if you ask to write down the electronic configuration of sodium, we can write down like this: 2, 8 and 1. This is the electronic configuration of sodium. And electronic configuration of ions, if asked you to write down configuration of ion as well, so this is the electronic configuration of ion with proton number 1 to 20. Like this is required for elements 1 till 20, like hydrogen till calcium. You should know how to draw the electronic structure and how to write down electronic configuration of the different elements. This is very important to know that group 8 noble gases have full outer shells, and why they are stable? Because group 8 elements are stable because they have stable arrangement of electrons. You can write down like this: the number of outer shell electron is equal to the group number in the, you know that it is very important to know that there are 8 groups in the periodic table, so 1 till 7. So outer electrons group number determine the outer valence shell electron, like group 1 1 electron, group 2 2 electrons, this is group 1, this is group 2, of valence shell has 1, valence shell has 2, group 3 valence shell has 3 electron. Similarly group 5, over here transition elements, and this is group 3 has 3 electron in valence shell, and group 4 4 electrons in valence shell, and group 5 5 electron in valence shell, and group 6 electrons. So group number determine the valence shell electron, and so on. 6 group has 6 electrons, 7 group has 7 electrons. This is transition metal. And group 1 2 are metals, group 3 are non-metals. So this is over here 3 group, and this is transition elements, this is transition 1 2 and transition metal. These are transition metals. Number of occupied electrons. So for example, number of occupied electron shell is equal to the period number. Period number determines, period number is the, this is the period number. Period number is horizontal rows, group number is vertical column. Vertical column are groups and horizontal are period. So period number determines the number of shells. For example, sodium is present in third period, so sodium has 3 shells. First shell has 2 electrons, second shell has 8 electrons, and valence shell has 1 electron. So this is about the atomic structure, and this context the question like write down the distribution. You should know the distribution of proton, neutron, electrons in any atoms of element. For example, sodium, this question is very important, like sodium examiner asked you to write down the proton number, electron number. In case of ions, in case of atom, for example, sodium has this structure. You have periodic table, you can take help from the periodic table about the, this is proton number, this is neutron number, and sodium atom has how many proton? 11. How many neutron? 12. How many electrons? 11, because number of electrons of any atom is equal to the number of proton. And in case of sodium ion, you know, proton number cannot be changed, and this is again 12, and now neutron electron number will be 10, because metals tend to lose electrons. So sodium is present in group 1, so sodium tend to lose 1 electron. Okay, so after losing 1 electron, it has 10 electrons in valence shell, 8 electron in valence shell, and total number of electrons is 10. So this is about the distribution of proton, neutron, electron, and you should know This is very important. This is very simple question. Please don't lose marks in this question. So please be careful while writing the number of proton, electron and neutron. And you have a periodic table, you can take help from the periodic table. Now next, number of occupied electron shell. Now come to the isotopes. Isotopes, in case of isotopes, definition is very, isotopes, you know, this is actually your definition. Isotopes as different atoms of the same element that have the same number of protons but different number of neutrons. This is the exact definition of the isotope. In it carrying 2 marks, please write down like this, that please learn this definition by heart, as different isotope is different atoms of same element that have the same number of proton but different number of neutrons, because students are commonly write down that uh, atoms have the same number of proton, but only this part, but you will lose 1 mark by writing this, that have same number of proton but different number of, write down always different atoms of the same element. So please start from this. This is the definition of isotopes. So state the isotopes of the same element have the same chemical properties because they have the same number of proton, and examiner commonly asks you to write down similarity and difference between isotopes of 2 isotopes. So always write down, this is again written the similarity, same chemical properties, this is the similar point, because please write down like this, that they have same chemical properties because they have the same number of electron, and write down that they have different physical properties because they have different neutron number. Okay, please write down like this, same chemical properties as they have same number of electrons, different physical properties, this is difference, different physical properties as they have different proton neutron number, as they have different neutron number, right? Is that clear? Different neutron number. Please don't lose marks in these simple concepts. Now interpret and use symbols for atoms. So this is the symbol of atoms and this is the symbol of ion. Okay, and you should know that distribution of proton, neutron, electron in case of isotope. For example, if chlorine is 17, 35 and proton, neutron and electron. So this is another isotope, chlorine 37 and 17. Over here proton 17, neutron 18, electron 17. Over here 17 proton, 17 electron, but number of neutron is different. So this is the distribution. You should know the distribution of proton and neutron and electron number in this context. Next topic is ions and ionic bonds. Describe the formation of positive ions. You know that metals always form positive ions. Metals of group 1, 2 and 3 form, along with transition metal, positive ions. Positive ions after losing of electron. After losing of electron. And you know that positive ions are known as cations and negative ions are known as anions, and non-metals form negative ions. Please keep it in mind. Non-metals form negative ions after gaining of electron. Describe the giant structure of ionic compound as regular arrangement of alternative positive and negative ions. You should know that ionic compound exists in ionic lattice. Ionic compound exists in solid state at room temperature and pressure, exist in ionic lattice, or ionic lattice definition is compound as regular. You please write down this sentence as well. Regular arrangement of alternating positive and negative ions. This is the definition of ionic lattice. Okay, don't write uh, detailed answer of this question. So just write down ionic lattice is a regular arrangement of alternate positive and negative ion. State that an ionic bond is strong electrostatic. Look at this. This is written in the subject content, and examiner is expecting that expecting you that you write down this force of attraction between the ions. So if you ask that why ionic compound has high melting point, write down that it is ionic lattice. Ionic lattice is the structure of ionic compound, and bonding, it has strong electrostatic force of attraction between oppositely charged ions which require high energy to break. So that's why ionic compound has high melting and boiling point. Describe the formation of ionic bond between ions of metallic and non-metallic. For example, this is example of like potassium chloride. So potassium in group 1, so write down like this. If you ask only valence shell, so draw empty valence shell because it has one electron gained by the chlorine. So write down positive charge over here, and this is chloride ion. Chlorine has 7 electron because it is present in 7 group. It is deficient of 1 electron, so which is donated by potassium are gained from chlorine gains this electron from the potassium. This is the dot and cross or diagram of ionic compound, ionic bonds. Okay, so just like draw like this. Describe and explain terms of structure and bonding of and properties of ionic compound. These two properties are mentioned, and only you ask these properties. Okay. Uh, you will ask that why, write down two properties. So write down high melting and boiling points, and good conductor electrical conductivity when aqueous and molten form, and poor when solid. Why good conductor in aqueous? Because has free moving ions. Don't write electrons, please. Free moving ions. So don't write electrons. So when solid, ions are fixed. Just write down that in solid cannot conduct electricity because ions are fixed. So this is about the ionic compounds, simple molecule and covalent bonds. So the covalent compounds are two types. One is a simple molecule and with covalent bonds. State that a covalent bond is formed when a pair of electrons is shared between two atoms leading to noble gas electronic configuration. So when they share their electron, they achieve electronic configuration nearest to noble gas. Like for example, HCl. If I want to draw HCl, so please draw like this. So now in mark scheme you will have observed that now examiner draw dot and cross diagram like this, and you follow this pattern as well. You know hydrogen has one electron, draw cross, chlorine dot, so this is dot, and this is cross. So draw like this, and you need to practice these molecules, especially these molecules: hydrogen, chlorine, water, CH4NH3 HCl, CH3OH. So this is the CH3OH. Hydrogen, sorry, don't draw like this because examiner is expecting that you draw like this. This is hydrogen, this is hydrogen, CH3OH, this is oxygen. Oh no, this is oxygen and this is hydrogen. we should follow the examiner pattern. Okay, mark scheme pattern. So this is oxygen and 2 lone pair over here. So this is like this. You have to draw dot and cross diagram of covalent compound, and you know that deduce how to deduce covalent compounds. CH4 in this both are non-metals, NH3 both are non-metals, HCl both are non-metals. So in this compound methanol all are non-metals. So covalent compounds are formed by mutual sharing of electron pairs between non-metals. Now describe and explain in terms of structure. Look here. So he's expecting you to write down in structure and bonding. Structure is all these molecules have simple molecule. These are simple molecule with weaker bonding is weaker intermolecule. Don't write covalent compound, covalent bond. Covalent bond is not a simple weaker force. Simple molecule bonding is in weaker intermolecular forces. Intermolecular forces which require less energy to break. So that's why they have low melting and boiling point. So low melting and boiling points in terms of weak intermolecular force are not required. Specific types names are not required. Just write down weak intermolecular forces. Poor electrical conductivity due to as they don't have free electrons. So they are poor conductor electricity, they don't have free electrons. Don't write ions, they don't have free electrons. So this is all about the simple molecules and covalent bonding. Now come to the giant covalent compound. There are 3 examples in giant covalent compound: graphite and diamond and silicon 4 oxide. You know, only written describe the giant covalent structure of graphite diamond. These are allotropic forms of carbon, allotropes of carbon. Diamond and graphite, this is carbon, this is carbon, and silicon 4 oxide is a compound. The common name is sand and formula is Si2. Relate the structure and bonding of graphite and diamond to their uses, limited to only these uses are required. Please don't learn other uses, just write down graphite. Why graphite as a lubricant and as an electrode? Electrode, as graphite has free electron, as it has free electrons, so that's why it conduct electricity, and electrodes are uh, uh, made up of carbon or graphite. And lubricant, why? Because graphite has one carbon has one free electron, and free electron delocalized, which form layer structure, layers slide over each other. So that's why they used as a lubricant. So only 2 uses are required, lubricant and electrodes. Diamond in cutting tools, only this use is required uh, uh, for diamond, that it is used in cutting tool. Why it is used in cutting tool? Because it is hardest structure due to presence of many strong covalent. Hard structure as it has many strong covalent bonds, strong covalent bonds which require high energy to break. Okay, metallic bonding. Now come to the metallic bonding as electrostatic. Look at here. Electrostatic attraction is very important to write down between the positive ions and a giant metallic lattice and C of delocalized. You can write down like this. Simple diagram. Draw simple diagram as simple as, but label it. This is positive metal ion and C of delocalized valence shell electron. Draw in box and draw electrons over here, 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 So this is the positive metal ion, and this is sorry, this is C of delocalized valence shell electron. So malleability and ductility, so why they are malleable, and this is second property. Examiner is expecting to write down that metals are malleable and ductile. Why malleable? Because metals arranged in regular layers and layers slide over. This very simple definition, layers slide over each other when force is applied. And similarly, ductility, malleability mean drawn into, beaten into shapes. This the meaning is beaten into shapes, and ductility drawn into wires, drawn into wires. So this is the how to define metallic bond. Look at this, this is the definition beta, very important definition. Don't write any other words. So metallic bond is the electrostatic force of attraction between positive ions and giant metallic lattice in giant metallic lattice between the positive ions and C of delocalized. This is the complete definition, bache. This is very important. Please write down, learn this definition by heart. Don't write any other definition. This is the definition of metallic bond. Explain in terms of structure and bonding the properties of metals. Good conductor length is very simple. Only two properties are given. You learn only two properties. Okay. Formula, state the formula and elements, compounds name in the subject content. Formula, representation of elements in terms of symbol. Define the molecular formula of compound as the number of types of different atoms in one. This is the definition written. Please, number as the number of types of different atoms in one molecule. Define the empirical formula of compound. This is again definition, simplest whole number ratio of the different atoms or ions in a compound. Reduce the formula of a simple compound from the relative number of atoms or ions present in a model or diagrammatic representation. Please write down, this is the definition. All definitions are written over here. Please follow these definitions. Deduce the formula of an ionic compound from the charges on the ion. For example, magnesium nitride. If we have magnesium nitride, so look at here, this is ionic compound because one is metal, other is non-metal. Magnesium is metal, nitrogen is non-metal. So magnesium carrying 2 positive charge, nitrogen carrying 3 negative charge. Charges are cross multiplied. These charges are cancelled out, numbers are cross multiplied, written as like this Mg3. This number is coming subscript of magnesium and this is subscript of nitrogen, Mg3N2. Hopefully to understand that how to form a formula of ionic compounds by cross multiplying the charges, because charge plus negative, because uneven number over here, uneven, this is negative charge, uneven number are become the part of the atoms and negative and positive charge cancel. Overall oxidation state of this compound is 0 because negative and positive charge cancelled out, and uneven, if same charges are there, so numbers are cancelled out. But over here, for example, look at here, sodium carrying +1, negative charges cancelled out, written as NaCl. Okay, please write down formula. Before write down formula, if you ask to write down formula, please confirm it from the periodic table, the charges, and how to do follow this method, and first cross multiply and then write down the formula. Construct word equations, symbol equations. Word equations, symbol equations, you should know the formula, name of the formula, chemical name of the formula. Ionic compounds, ionic equation to show how reactants form products including state symbol. If examiner asked to write down state symbols, then the marks of state symbols are given, and the question in 23 is there that only he is asking about the state symbol. So write down only state symbol and carrying 2 marks. This is very important to know the state symbol of the reactants and products. Deduce the symbol equation with state symbol for a chemical reaction given relevant information. Okay. Relative, for example, if examiner asks that magnesium react with oxygen to form magnesium oxide. So he asked you to write down chemical equation for this reaction to form magnesium oxide. So this is very simple. He asked you, he write down the reactants as well as products. Please be careful, this is answer written in the question. So this is magnesium, symbol of magnesium. You can take help from the periodic table. Oxygen, this is symbol of oxygen, write down like this, magnesium oxide, and then balance oxygen over here 1 2, place 2 over here to balance magnesium, so 2 over here. So this is how to write down. If you ask to write down state symbol, so magnesium, all elements exist in solid state except mercury and bromine. So all elements exist in solid state except mercury and bromine are in liquid state. This is liquid, only mercury and bromine, and these are the gases in the periodic table: H2, N2, O2, F2, Cl2, and all group 8 elements. 8 elements. So these are the liquid. Rest all elements are solids, exist in solid state. Describe relative atomic mass. This is the definition of relative. Please learn these definitions. This is very important, definitely will come in exam. Relative mass of the isotopes of an element compared to 1/12 of the mass of an atom of C12. Define relative molecular mass as the sum of the relative atomic masses. Relative molecular masses will be used for ionic equation. Yeah, this is the relative molecular mass. Sum of the relative atomic mass of molecule compared to 1/12 of the mass of an atom of C12. So this is the definition of MR, and this is new addition, and definitely will ask in exam. So please learn these definitions by heart. This is definition relative molecular mass, this is definition, this is relative atomic mass. Okay. So next, mole of the Avogadro constant. State the mole that the mole is the unit of a mass. This is the definition of mole, and 1 mole contains 6.02, and this is mole is equal to number of particles. This is formulas, number of particles divided by Avogadro number. And what is Avogadro number? 6.02 into 10 raised per 2, 23 Avogadro number. And particles can be atom, molecule, ion. Look at here, particles, atoms, ions and molecule. This number is Avogadro constant. Use the relationship mole. This is the mass over mR, molar mass or gram per mole. So calculate amount of substance, mass, this is amount of substance. This formula is amount of substance. You can find out mass like this. Mass is equal to mole into AR or MR. AR is the relative atomic mass, MR is the molecular mass. So this is molar mass. This is known as molar mass. When you calculate like this is known as molar mass. For example, 1 mole of sodium chloride and its mass is NaCl. For example, calculate molar mass, 1 mole into 58.5. So 58.5 gram is the molar mass of sodium chloride. Relative atomic mass, relative molecule, again this definition very important. Number of particles using the value of the Avogadro constant. This is the formula of Avogadro constant. So Avogadro constant 6.02 into 10 raised by 23. Use the molar gas volume taken as 24 dm cube at room temperature and pressure in the calculations involving gases. State that concentration can be measured in gram per dm cube, mole per dm cube. So gram per dm, this is mole per dm cube, mole per dm cube is equal to mole over 1001 dm cube. And how to convert gram per dm cube into mole per dm cube? If you asked to convert gram per dm cube into mole per dm cube, so if you have gram per dm cube, look at here, gram per dm cube is equal to mole into mole per dm cube into mR. And if you ask to convert mole gram per dm cube into mole per dm cube, so this is the answer, gram per dm cube over mR of given compound, whatever the compound is, okay, mR of x, any compound mR of x, okay. So this is how to convert gram per dm cube into mole per dm cube, mole per dm cube into gram per dm cube, and gram dm cube into mole per dm cube. Calculate the stoichiometric reacting masses, limiting reactant which is smaller in amount and which is used in the chemical reaction. When limiting reactants is used up, reaction is over. Volume of gas is at RTP, volume of solution. So this is the volume of solution, mole is equal to concentration into volume in centimeter cube. Please use this formula, and this is manipulate, you can calculate volume as well as concentration as well as mole. This is the formula of mole of liquid, this is mole of solid, this is mole of particles, this is mole of gas. Mole is equal to volume of gas over 24 decimeter cube volume. So this is, these are the 4 formulas. One is this mole of gas, this is mole of liquid, this is mole of, this is mole of liquid, this is mole of gas, and this is mole of particles, and this is mole of solid. This formula is mole of solid. Okay. So hopefully you can calculate, it will help you a lot while solving the questions. Next topic is electrochemistry. Define electrolysis as the decomposition of, this is the definition of electrolysis. Please write down this definition. Don't write any other definition. Solution by the passage of an electric current, bus only this definition. You will get full marks because this is the syllabus content and same definition is written in your mark scheme. Identify in simple electrolytic cell the anode as the positive electrode. This is the electrolytic diagram. So draw like this. This is a solution, electrolytes. This is negative electrode. This is positive electrode. This is anode. This is cathode, and over here electrolyte are ionic compound which conduct electricity. So anode as positive electrode, cathode as negative electrode, electrolyte as the molten or aqueous substance that undergoes electrolysis. Describe the transfer of charge during electrolysis to include the movement of electrons in the external circuit, movement of ions in the solution, and this is very important, movement of electrons when any ions lose electrons. So electrons are moving in this circuit and ions are moved in the solution. So loss or gain of electrons at the electrodes. At anode, electrons are losing at anode, electrons are losing which are travelled in the electrical wire, and at cathode electrons are gained, electrons are gaining. At anode oxidation takes place, at cathode reduction takes place. This is very important to know. Movement of ions in the electrolyte, look at here please, this is very important to revise, to last minute revision. Please do follow the syllabus content and do write the definition according to the syllabus content, because everything is written in the syllabus content. Movement of ions in the electrolyte. Identify the products formed at the electrodes and describe the observations made during the electrolysis of these 4 compounds are written. Look at lead bromide, the formula is lead bromide PbBr2, anode reaction is 2Br negative to form Br2 plus 2 electron. This is molten form. Cathode, this is gas, sorry. So he ignored the state symbol now. So this is now lead is gains electron to form Pb, and this is the observation of this lead is silvery lead. Deposited under the cathode, not on the cathode, fall under the cathode because this is the heavier metal, cathode. And bromine, in case of bromine, brown fumes or orange fumes. Now in this mark scheme 23 to 25, your syllabus is 23 till 25, and in these papers brown, he asked you to write down orange instead of brown. So write down orange fumes. Brown fumes are also acceptable, but try to write down orange fumes. This is new addition of the syllabus. He write down the color of this gas is orange. Now concentrated aqueous sodium chloride, you know that this is the concentrated sodium chloride anode reaction. This is concentrated, word concentrated. Anode reaction is 2Cl negative to form Cl2 plus 2 electron. Cathode reaction is 2 hydrogen positive to form H2, plus 2 electron to form H2 gas. This is gas, this is aqueous ion. Now dilute sulfuric acid, in case of dilute sulfuric acid, I write down over here, sulfuric H2SO4, dilute or concentrated same, 2H positive, sorry, this is reaction at cathode. Anode reaction is 4OH ion, H2O, 2H2O plus O2 plus 4 electron. And cathode reaction very simple, hydrogen gas, 2H plus 2 electron to form H2. And you know that in case of cathode, always write down the electrons on the product side, reactant side, and in case of anode, write down the electron on the product. This is oxidation and this is reduction. Hopefully you understand this topic. Using inert electrodes made of platinum and carbon, identify the products formed at the electrodes and describe the observation made during the electrolysis of aqueous copper 2 sulfate. This is very important question, and this will definitely come in the exam in any context. This is copper sulfate with carbon. Anode reaction is 4OH negative ion to form 2H2O plus O2 plus 4 electron, and cathode reaction is Cu2 positive plus 2 electron and copper solid. And cathode mass increase because copper deposited at the electrode and color become fade. Cathode mass increase, and color change is blue to colorless. Blue color fade, write down, or blue to colorless, click, so anything is acceptable. Blue color become fade and solution become acidic because hydrogen ion and sulfate ion remain in the solution, which make solution acidic. So that's why color become fade. And during using copper electrode, copper sulfate with copper electrode. This is the reaction at cathode anode. Pure copper at anode, impure, and cathode pure. Reaction at anode, copper solid dissolves to form copper ion plus 2 electron. Oxidation on copper, 2 electrons gain 2 electron and copper deposited at cathode. Blue solution changes, anode mass decrease, cathode mass increase, and color remain blue. So these are the changes after the electrolysis. Hopefully you understand this video and these topics up till now. Now in next video I will discuss the detail of other topics, inshallah, very soon. Thank you.